So now let's create a route table to go along with this here. So let's go resource AWS Router Table, and we're going to call this one public. I want to show you what it does in just a second, but we do AWS VPC here again. So the same VPC as always, and then we do route signup block is equal to 0.0.0.0/0. So basically for everything we do gateway ID is equal to AWS Internet Gateway .microservices demo.id. So this basically allows all of our things coming in and coming out to basically all go through the internet gateway and just pass straight through. So we have essentially complete transparency here, you could call it, so that it passes straight through. But what we actually do is we also have our subnets, and our subnets actually control that here. So we essentially just allow all of it through here, and we do tags is equal to name public route table, like so. So we have this set up here now, and what we're going to do is just do a resource here, and we're going to call this one AWS Route Table Association, and then we're going to do microservices demo subnet public, and we're going to do subnet ID equals AWS subnet dot microservices demo subnet public dot ID, and then route table ID is equal to AWS route table dot public .id. So like I said, we have this one here in our VPC, but we're now associating it with a particular subnet, specifically the one that is public. So basically it allows all our public stuff to be accessed via the internet. So now we have our route table here, and we have our subnets. Now we're going to add some security groups. So now let's go down here and let's do resource. And we're going to add a couple security groups. Security groups basically represent certain requests which are allowed or not allowed. So the first one here we're going to do is AWS security group, and then allow internal HTTP. And the name, just match that name there inside of here. And then description is going to be allow internal HTTP requests. So this one, once we set it up, it's going to be used by our API gateway, or it's going to be applied to our listing service and our user service, and it's going to be used by our API gateway to request information from those two services. So we have these two here, and then VPC ID equals AWS VPC.microservices demo.id, and then ingress, which means when we are coming in, so incoming requests from port 80 to port 80, the protocol is TCP, and then CIDR blocks basically is going to be 10.0.0.0.16. So let me explain what's going on here. We have from port and to port as the same number, so basically a single port 80, which is what HTTP runs on. The protocol is going to be TCP, which is what we use here, and the CIDR blocks basically represents which ones are allowed. So the ones that are allowed specifically are 10.0.0.0.16, which you'll notice are only the ones inside of the VPC. So what we can actually do here is if we have a look at go into Chrome here, we type in VPC up here in the top. So we go to the AWS VPC resource, and then if we go down to attributes reference, we can actually grab that CIDR block instead of hard coding this name. We can grab AWS VPC.microservices demo.CIDR_block like that. So that's this one here, and we're going to specify that inside of here, which basically just removes one more hard coded thing from within our code. So now that we have this one here, let's grab this whole thing and just duplicate it. And now for this one here, instead of writing HTTP, we're going to write MySQL there like so. And this one's going to allow internal MySQL requests like that. And then here we're going to, instead of port 80, the port for MySQL is 3306, still TCP here. And now after that, we're going to add one more. So grab this whole thing one more time. And this one's going to be allow HTTP. So this one is different to allow internal HTTP because this one also allows external HTTP from the public as well. So now we're going to change the name to allow HTTP. And this one's going to be allow HTTP inbound traffic. So basically coming in, and then it's going to also have that. The port is going to be port 80, and the CIDR block is going to be 0.0.0.0.0. So basically any IP address is allowed. Let's add one more here as well. And this one we're going to call it allow SSH. So if you remember before, we had to kind of change the default security group to include this rule. Now we're doing it here. So we do allow SSH inbound traffic, and this one's going to be on port 22, which is, as you'll remember, the one we used before. So now one final thing we're going to do, grab this one more time, and instead of allow SSH, we're going to call this one allow all outbound. And this one allows all outbound traffic. So basically traffic coming from, or network requests coming from within your instance to the outside world. So that's what we have here, microservices demo, and then from port to port 0. So basically, and then we do protocol -1, which means it allows everything. And then CIDR block once again, just that one there like so. So now that we've got all of these things set up, let's create a new file here as well. And we're going to call this one API Gateway .tf. So now we're going to, inside of this file, create all of the stuff we need for our API gateway. So the first thing we're going to have is a resource here, which is going to be an AWS EIP. So EIP stands for Elastic IP, and you need to have an Elastic IP address if you want to be able to access the internet. And also in our case as well, if you want to be able to actually access this from the public. So we need to have this here if we want to actually access this from the internet. So then let's do API Gateway here, EIP like that. And then instance equals module.api gateway dot instance ID, and I'll show you how this ties in just a second. So let's go down here to module API gateway. Source is going to be our node server. So we're going to set this up here. AMI ID is equal to, and let's grab that one from EC2 here. So type in EC2. We're going to grab the one for the Linux image. So go to instances, launch instance, and grab this ID here. Put that one inside of there. And now let's do key pair is equal to AWS key pair dot microservices demo key dot key underscore name. Let's do key pair key is equal to dot slash microservices demo dot key. So this one here. Let's also do name is equal to API gateway. Subnet ID is equal to AWS subnet dot microservices demo subnet public .id. So this one's going to be part of the public because we can access the API gateway. And for VPC security group IDs, we're going to write in here AWS security group allow http.id. So we can take in external HTTP requests, allow SSH.id, so we can SSH into this, and then also allow all outbound.id. So basically this allows all outbound connections, which we need as well. So now that we have this set up, what we're going to do is create a new file inside Terraform again, and we're going to call this one outputs.tf. So when you have a root file called outputs.tf, it actually outputs this into the terminal when we're running our command. So it outputs what we need it to. So in our case here, we're going to do output API gateway, and we're going to output the private IP, which will be value module.api gateway .private IP. Now let me explain to you how this got here. So if we look inside this file here, we have the module API gateway, and this one comes from node server. So if we go into node server here, we have variables, outputs, and inside of outputs here, we have private IP, which comes from AWS instance default private IP, which comes from this instance here. So basically it gives us the private IP address of the EC2 container that was created. So now we have this one here. We're going to grab this and go down here, and we're going to call this one public IP. And instead of doing this, we're going to do AWS EIP.API Gateway EIP. So that's this one up here, dot public underscore IP. So now we have both the public and the private IP. So if we go into Terraform here, so into terminal, and we type Terraform apply, you notice that we get an error saying this module is not yet installed. So in order to fix this issue, you just need to run Terraform init one more time. It will go very quickly. And then let's do Terraform apply, and we get an error. So we have our error which says key pair key inside of API gateway, which reminds me, I completely removed that. So we can get rid of this one as well. It's not used anywhere. So get rid of that one line, go back here, run it one more time. Let's type in yes, and let's wait for all 17 of them to get created. Okay, so now you notice we have a private IP and a public IP. So if I grab this public IP address, I can actually SSH in again. So SSH and paste that in there. And if I type yes, then we should be able to go in, and we should have Node. Node is not installed for some reason. We also don't have yarn, and we also don't have npm. That's really weird because it's meant to give us all of those, but for some reason it hasn't given us all of those. We do have an init.sh, but somehow this file is not working. Let me try run this file and see what happens if I run that file there. Okay, so it seems like the problem is that we actually don't have access to the internet. So this is an issue which I said before. For some reason, I didn't get it set up properly. It's meant to have access to the internet. I'm going to try to figure out why it does not. Okay, so this was my bad. This one here is not meant to be ingress. Ingress means coming in. If you want it to go out, it has to be egress. So that was my mistake. Now that I've done that, we should be able to go into terminal here, close this SSH connection, try Terraform apply one more time. It will notify us on what we need to change. So it seems like we just need to change two things here. So the AWS instance there needs to be changed in place to use the new security group ID, which we're going to update in place to have egress and not ingress. So anyways, now let's type in yes here. And now that we've done that, we get an error saying VPC-based instances require at least one security group to be attached. Now, that seems like an issue with this one here. Now, however, the thing with this one here is that we do have outbound there. And we are just going to do Terraform destroy, which is going to get rid of everything and allow us to start from a clean slate. So this really helps us to see if this is a Terraform issue. Sometimes there are certain problems which come up as a result of Terraform, and sometimes it is your code that is the issue. So I'm going to try destroying everything first, simply because we don't have any valuable data in here or anything at the moment. So I'm going to destroy all of that and then see if that helps at all after I recreate it. Okay, so now let's do Terraform apply. So just go here and type Terraform apply and let that run as well. Okay, so now you can see it actually got created properly, which is pretty cool. And like I said, sometimes that just does happen. So now let's grab this IP again. Let's do SSH into this one now. And let's go in and let's try type node, type nvm, type yarn, and all of that stuff is there. So it's working all fine and we created it and now it's all there. So this is really cool because now we have our API gateway set up. Now what we're going to do is go into Terraform again, create a new file, and this one we're going to call listingsservice.tf. So this is going to contain all of the stuff for our listing service. Let's grab everything we have for API Gateway and paste it inside of here. Now we can start off with this, just grab the API Gateway word here and just do that. And let's just type in listings service instead. We keep the same AMI ID here, the same subnet ID, all of that, but we also specify a private IP. And this one we're going to use 10.0.1.5. And for the subnet ID, instead of using public, we're going to use private 1. So now I want to show you something, which is inside of networking.tf. If you notice, if we have a look at our private 1 subnet, we use 10.0.1.0/24. Now, if we go back into Chrome here and grab that cider thing that I had before, so cider.xyz, and we grab 10.0.1.0/24, you'll notice that these bits are all set in stone, but these ones here can change however they want. Now, the reason that we use 10.0.1.5 is actually the first 4 are used, so 1, 2, 3, 4, and also 0 are used by AWS, so we have to start at 5. So we start with 5 here, and that is why we have this private IP. Now, why do we keep the private IP as static? Because when we access it from the API Gateway later in the series, we're going to be using this IP address exactly. So we don't want the private IP to change. Just within the VPC, we want this to always be at a stable static address. So we have that here, and instead of allow HTTP, we're going to use allow internal HTTP, which allows us to access it. If you remember here, internal HTTP allows us to access it from the VPC CIDR block, which basically means from other stuff within the VPC, which allows us to access it from the API gateway, because this is also within the VPC. So now we have this here. We're going to go down here and write module listings service DB. So we have a database for that as well. And we do source equals MySQL DB like that. And we do apply immediately is equal to true. Like I said, this is very useful for testing. DB name is going to be DB. DB subnet group name is going to be AWS DB subnet group.private.id without the double quotes. So this one here is the one that we wrote inside of networking at the very top. Is this private subnet group, that one there. And then identifier is going to be listings service DB. Password, and we're going to do var.listingsServiceDB password. Now we haven't created this yet, but let me just finish writing this part here. So publicly accessible is equal to false. Username is going to be var.listingsServiceDB username, and we're going to do VPC security group IDs is equal to AWS security group dot allow internal mysql.id. So this one here is this one here from networking. So allow internal MySQL, which basically allows us to access this from a different EC2 container. So within the VPC once again. So we have all of this here, and now we have listing service DB password and listing service DB username. So let's go into variables here and let's add those two in. So variable listings service DB password type equals string. Grab this, duplicate it, and do username here. So now we have the password and the username. So we go into terraform.tf vars and we add in these two. So let's write listing service DB password, and the password we're just going to do M1CROSERVICES, so microservices with a 1. Feel free to use whatever you want here. This really isn't too big of an issue. And then for the username, we're just going to use user. So now we have those two there. And now we're going to go back into here. We have our listing service DB and our listings service done. So now let's grab listing service. Let's copy this, paste it, and let's name this file users service. So now for this file here, just grab the word listings and replace all of them with users, because the two other than that are pretty much identical, except this one here becomes 10.0.1.6. So now after you've done that, you should be able to go into your terminal, type Terraform apply, and you'll get this error once again. So you need to Terraform init, and then now Terraform apply one more time. And it seems that we get an issue with the user service variables, because I totally forgot to include them here. So I'm just going to grab this, duplicate that as well, go here, type users there, Terraform TF-vars, grab this. I'm going to use the same username and password. Feel free, like I said, to change it to whatever you want. And now let's do Terraform apply one more time. Okay, so now we have that done, and you see that our output still only has the API gateway. So what we can do is go into outputs here. So now let's grab this output section here, paste it twice. And for this one here, we're going to do listings service. And for this one here, we are going to do users service. So just like that, and save. And now let's run Terraform apply one more time. Now this time it should be a lot faster because it doesn't actually need to create any resources. It just reads through everything, and then it should just output us the latest information. So we just need to do one change for some reason. I'm not sure why this is the case, but it seems like we need to change the security group ID for the default one. Not sure why. Just type yes there, see what happens. And we get this error. So it seems like every single time we do it, we get the error. And I think that is because of our test server. So what we can actually do now is if we get rid of this test server file, and I mean, I probably should have done this quite a while ago. Now, if we run Terraform apply one more time, it should ask us to remove this whole thing altogether. And that should be exactly what we want to do. So let's go here and just type yes, let that get removed. Great, so now we have that resource deleted, and now you see we have listing service private IP and also users service private IP there. So now we have all of our resources created, and if we actually go over into Google Chrome and we go into our EC2 over here, so just go to EC2, click on instances, and you'll notice that we have 3 that are running. So we have our listing service, we have our API gateway, and we have our users service. Now these do seem to have a public IP, but if we try to access it via that public IP there, so say we copy this one for, not for the API gateway, sorry, for the listing service. If we try to go into this one here, and we paste that, we type in yes, it lets us in for some weird reason. So that shouldn't be the case. Listing service should not let us in, and user service should also not let us in. I'm not actually sure why this is happening, so I'm going to have to debug that because I think, oh wait, no, it's because I didn't copy. So let me just copy this one to clipboard and get out of that, and let's paste in this one here. So for our user service, it should give us absolutely nothing. And then for our listing service, it should be the exact same. So now if I try to go to the listing service, it should also just stall there. So there you go. Both of those cannot be accessed publicly. So that's really great. And now let's go to RDS here, and you'll notice that inside of RDS, if we go over into databases, we have 2 databases here, listing service DB and also users service DB. So we have those 2 there as well. And now if we go here and we type in VPC and we have a look at our virtual private cloud, you'll notice that all of our VPC resources are set up here as well. So for example, under your VPCs, we've got 1 and also this one here, which is the default. So don't worry about that. This one here, and inside of subnets, we have our 3 subnets. So the 2 private ones and the public one as well. We have our route table, public route table there. Internet gateways, our one doesn't have a name. We probably could attach a name, probably should, but that's this one here, which is this one here. And elastic IPs, we've got 3 of them for our applications. And also inside the security groups, we have a couple ones. Allow internal HTTP, allow SSH, allow internal MySQL, allow HTTP, and allow all outbound. So we have all of those here. Now, one more thing I want to do is go into our outputs.tf here. And we're actually going to add in the database address. So basically, let's go here and let's just do output listings service DB address like that. And let's go into value equals module.listings service DB. So you notice that this one comes from this one here. And if we look at the outputs there, we have address. So we can just do dot address straight onto there. Copy that, and let's also put it here as well. So we have one for the user service. So we have listing service DB address and user service DB address. So this will show us the address of our database. And now if we run Terraform apply, it shouldn't make any changes. But now that we do this, it should also give us those 2 outputs. So we'll let that run. And now you notice we have listing service DB address and also users service DB address. So this is the location of our database. And now if we go over here into terraform.tf state, this is the file I want to show you. So this file and Terraform tf-state.backup, both of these should be git ignored as well. But this file here contains a whole bunch of useful information, including all of our outputs and also all this data for every single one of our resources. So this is a very important file, but it's not one that you need to commit into GitHub, because it could definitely contain information you don't want to show. So anyways, we have this file here. Like for example, it also contains the password. So like the password is everything is in there. So you definitely don't want to commit this file here. So now we have our MySQL database set up. We have our Node server set up. So now the next step that we need to do is get all of this working inside of code deploy so we can actually deploy to our services.